Hello everyone, my name is Mohammad Mukarram Ahmed Ansari. I have done my project on fabrication of electrospun molybdenum disulfide polymer nanofibers for electrochemical sensing application under the guidance of Dr. Chandrukumar sir and Dr. Manjunath sir. First, the outline of the presentation. This abstract, objectives, introduction, materials and methods, results and discussion, conclusion and future scope. A brief introduction of the project. Biosensors plays a significant role in the process of early diagnosis of diseases. In global market, this type of sensors were valued at over 17 billion US dollars in 2018. Molybdenum disulfide nanomaterial finds applications in electrochemical sensors, but electrospun composite fibers fillers have limited usage in the field of biomolecule sensors due to lack of conducting properties. In this context, many research works focus to develop high conducting nanofibrous fillers by many methods, but only few investigated on biomolecule sensing application. The objective of the work was to develop PU-PANI MOS2 nanocomposite fibers by optimizing the parameters of electrospinning and characterized for detection of biomolecule. Optimized properties of MOS2 were obtained at 0.6048 grams of sodium molybdate and 0.16 gram of sulfur at 180 degrees centigrade for 24 hours. The diameter of the electrospun nanofibers produced was 175 nanometer by optimizing electrospinning parameters, applied potential to 13 kilowatt, flow rate condition to 1 ml per hour, and concentration 10 weight percentage. In differential pulse voltammetry, testing the developed composite requires 20 seconds of deposition time for it to sense ascorbic acid and give a redox peak potential of 0.34 volt at different concentration. Our objectives of the project: to synthesize and characterize the unique nanostructures of molybdenum disulfide, analyze and optimize the synthesis parameters of nano-MOS2 preparation method, optimize electrospinning process parameters, then fabricate and characterize nano-MOS2 embedded PU-PANI nanofibers, test biomolecule sensing of nano-MOS2 embedded PU-PANI composites. This is the methodology what we have followed in our project. First, hydrothermal synthesis of nano-MS2 by varying composition of solvent, precursors and process temperature. Then characterization of nano-MS2 by XRD and SEM, and fabrication of PU nanofibers by electrospinning by varying electrode potential, flow rate, viscosity and tip to collector distance. Development of nano-MS2 embedded electrospun PU-PANI composite. Testing of sensor for detection of ascorbic acid. First of all, first step in our project is the preparation of nanomaterials. It is done by hydrothermal method. Hydrothermal method. In this method, chemical reaction of molybdenum and sulfur precursors at the critical point of the solvent is sealed vessels. Reaction at critical point increases rate of reaction and assists nucleation. Size and morphology of nanoparticles can be modified by varying reaction time, temperature and precursors. Hydrothermal process consists of two phases: nucleation, growth. As you can see in the figure, here the nucleation start, the nuclei presents and the precipitation occurs and the growth of the crystal occurs. Then this is the this is the equipments used during experimentation. These are the Teflon tubes. In these are the sealed containers, and this is the hot air oven. This is the hot air oven in which we have kept for 180 degrees centigrade for 24 hours. This is the centrifuging machine, and this is the nano material what we have obtained. This is the procedure of the experiment. This is the materials which we have used for the development of nanomaterials. First set of experiments, are the same results what we have got from this. These are the shape like structures, spheres like structures which they are present, and further in the magnification we can see that in that sphere the fibers like structure are present. The MOS2 presence is confirmed by the exadic crystalline structure. This is the second set of experiments. In this set, spongy cotton-like structures are obtained, and in the third set, same cluster of spongy cottons occurs. The next step of our project is that the synthesis of nanofiber by electrospinning method. This is the electrospinning method setup. This is the mandrel, this is the syringe, and this is the pump. So what are the experimental procedure for electrospinning? First, we have used THF and DMF in the ratio of 3:2 and weight percentage for 10, and what we got of the weight of the polymer is 1.702 grams of 702 gram of polymer. Then second, the process optimization of PU nanofiber occurs. Each of the parameters, flow rate, applied potential, and solution concentration was individually varied while keeping all the other parameters constant to study each of the influence on fiber structure and diameter. First, optimization of flow rate. What we have done is the solution concentration and applied voltage are kept constant and flow rate will be changed. In that, we have optimized that the flow rate ml per hour is 1 for the minimum diameter of the polymer. This is the same images what we have got. Second, the optimization of voltage. In this set of experiments, solution concentration are kept constant and flow rate is kept constant, and the applied voltage is changes from 13, 15 to 17. In this, we have got the minimum diameter at 13 voltage. 13 applied voltage. This is the same images what we have got. And the third one is the optimization of solution concentration. In this set of experimentation, solution concentration is varied and applied voltage and flow rate are kept constant. In this whole parameter, these are the results what we had achieved to get the minimum diameter of the experiments. In this, the solution concentration is 10, applied voltage is 13, flow rate is 1. And these are the same images of the third step of our project is the polymerization of PU, poly and polyaniline. First, these are the procedure what we have followed for the PU polyaniline polymerization. And these are the same images of the PU and PANI composites. As you can see here, these are the very good structures what we have got from the same images. And this is the IDAX that shows the presence of carbon, oxygen, and nitrogen. And this is the FTIR of the polymerization of PU and PANI. And further we have polymerized PU, polyaniline, and MOS2 combined. This is the procedure what we have followed, and these are the same images. Here you can see that on the fiber it is clearly visible that the the coated MOS2 is very well coated on the fibers. See here, as you can see here, it is very well coated so that it will be very good for the uh, purpose of electrochemical sensing. As you can see here in the IDAX, it will shows molybdenum, sulfur, carbon, oxygen, and nitrogen. And this is the FTIR that shows the crystallinity and the bonding gap. The final step of our project is the electrochemical sensing. This is the electrochemical workstation. This is the electrochemical sensing part. Here is the reference electrode, platinum electrode, working electrode, and it is the specimen ascorbic acid test. Here is the graphite rod which we have used. Nanofiber is placed between the graphite rod as you can see here in this picture, and these are the buffer solutions what we have prepared for the electrochemical sensing. The next step is to test our fiber for in differential pulse voltammetry to verify nanocomposite ability to detect ascorbic acid and to obtain voltage at which oxidation of AA occurs. The working electrode is dipped in 1 ml of ascorbic acid solution of 2.5 mol with 8 ml of phosphate buffer and 2 ml of 0.1 kCl solution. The sensor interface is scanned at the rate of 10 mV per second. Voltage varied from minus 0.5 volt to 0.8 volt. This is the differential pulse voltammetry of the sense vitamin C, ascorbic acid. As you can see here, as the concentration goes on increases, the detection level also increases and the graph also increases. These are with the bare electrodes, and these are the concentration of 3 ml, 4 ml, 5 ml, 7 ml, 10 ml and 20 ml. This is the comparison of the results with the standard results. This is the standard results and this is our experimental results, which will be in agreement with the standard results. Further, we have what are the effects of deposition time on that, and as you can see here, the time interval changes steps are 10 seconds between each trial. This is the deposition potential, and we can see here at 0.34 volt it is the maximum. What are the effect of pH? We have different buffer solution of pH ranging from 3 to 9, and what we have concluded is that on pH level 8 it is maximum sensing of ascorbic acid, and this is the effect of ascorbic acid. As you can see here, it is the linearity of ascorbic acid detection. Lastly, conclusion of our project. Parametric optimization of electrospinning was carried out and the following parameters were fixed for the study. Flow rate of spinning solution is 1 ml per hour. Applied potential 13 kilowatts. Concentration 10 weight percentage. PU nanofibers of 175 nanometer in diameter were developed by electrospinning. MOS2 nanoparticles were synthesized by hydrothermal method. Further, the PXRD study revealed that the nanoparticles obtained were of dignified phase. PU Pani MOS2 nanocomposite were developed by polymerization process. The developed nanocomposite was tested for biomolecule detection by electrochemical method, and the electrochemical sensing parameters were determined. Future scope. The present study can be extended to study the interface of other biomolecules such as dopamine, uric acid, and glucose in the determination of ascorbic acid. Secondly, commercialization of developed sensors can be done. These are the references which we have followed. Thank you very much.